So good morning my dear students. Today we are going to take the new chapter, and that is the last chapter of trigonometry, third, that is trigonometric ratio of complementary angles. Okay, so let us understand this chapter, but first let us understand the basic of it. So the basic says complementary angles and their trigonometric ratios. So I hope you know what do we mean by complementary angles. If I take two angles, that is alpha and beta, then the complementary angle says that the sum of the two angles which gives 90 degree, then these two angles are complementary to each other. And similarly we know about the supplementary angle, that if two angles on adding them, if we are getting 180 degree, then we can say that alpha and beta are the supplementary to each other. But in this we are going to see only the complementary angle, that is what do we actually mean by the complementary angle and their trigonometric ratios. Okay, so first of all, say for example, if you have a triangle, a 90-degree triangle, and if you have theta here, and if I ask you what will be theta here, what will be the angle here, then angle C will be equal to, by using the angle sum property, that all the three angles are equal to 180 degree. So how can we find this C? By subtracting the sum of these two angles from 180 degree, that is so this angle will be 90 minus theta. Okay, now keeping in mind, if we have one angle 90 degree, another angle theta, then this will be 90 minus theta. So if I ask you what will be your 90 minus sine 90 minus theta, first of all the thing is sine theta is equal to, if this is perpendicular, if this is base, and if this is hypotenuse, then sine theta is equal to perpendicular upon hypotenuse, we know. And if I ask you what will be this, so this is 90 minus theta actually. So sine 90 minus theta is perpendicular. What will be the perpendicular now? If this is the theta, then the opposite one becomes the perpendicular. So now this is your perpendicular and this is your base, and hypotenuse is always the same. So can you tell me what will be the perpendicular here? This will be the perpendicular. So AB upon what will be the hypotenuse BC. And if I see, perpendicular and base. If I ask you what is cos theta here, so cos theta is what? Base upon hypotenuse, AB upon BC. AB upon BC, here also AB upon BC, AB upon BC is cos theta. So in place of AB upon BC, can we write cos theta? So what from here we understood that sine changes into cos while doing 90 minus theta, and similarly cos 90 minus theta, you will get sine theta. So this is what conversions we are going to see in this chapter. Okay, so you have to write this thing, and what you have to write the another thing, that how function changes into its co-function. So first, after writing this, you write function and co-functions. Now I'll tell you what are functions and co-functions. If you take sine, then the co-function, put CO in front of this sine, so you will get cosine, or we call it as only cos. So sine changes into cos. Similarly, if I take sec, it changes into its co-function, and we write co here, so it becomes cosec. Similarly, if I take tan, then it changes into its co-function, and we write cotangent, or in a simple way, cot. So this is how function changes into its co-function when we put 90 minus theta. That is what I'm trying to say, that if I remove this arrow and if I write 90 minus theta, then I get cos theta. Here also if I write 90 minus theta, I get cosec theta, and 90 minus theta, so cot theta. So sin 90 minus theta is cos theta, sec 90 minus theta is cosec theta, and tan 90 minus theta is cot theta, and they are vice versa also. Cofunction and function. Cofunction cos, cosec, cotangent या cot, they cofunction changes into its function. Okay, if function changes into its cofunction, then cofunction again changes it into function. So if sin 90 minus theta is cos theta, so cos 90 minus theta will also be sin theta. Sec 90 minus theta is cosec theta, so cosec 90 minus theta will be sec theta. Tan 90 minus theta is cot theta, so it will be tan theta. So this simple things you have to understand. Function changes into its cofunction, and cofunction again changes into its function. So you have to remember this table. Okay. If you go through the note, that is a note is given in the basic part, that you can represent 180 degree in terms of pi. Actually the angle can be represented not only in the degree, but in two more systems which you will study in the 11th class. Till now you are only understanding the till now you have studied that the angle is represented in degrees, but it can be represented in grades and the radian. So that is what they have given a small highlight, that 180 degree can be represented in pi. So 1 degree can be represented in pi by 180. Can you express 30 degree? So 30 into pi by 180. So it will be pi by 6. So 30 degree can be represented in pi by 6 also. So it's just a normal thing. You don't have to study this much, but you should know that we can represent in radian also. This is called pi radian. 180 degree is called the pi radian. Okay. Okay, let us come to the exercise. The first question, evaluate. Without using table, you have to evaluate the things. Now we are going to use the conversion which we have seen right now. Very first question I'm doing, cos 80 degree upon sin 10 degree. Now we don't know the value of 80 degree and 10 degree. We only studied about 0, 30, 45, 60 and 90. Now how to solve this one? Okay. Always remember, in such type of rational questions, change only one function. So what I'm doing, this cos 80 degree, and I'm keeping it as it is, sin theta. I told you that sin theta is what? Cos 90 minus theta, or cos theta is what? Sin 90 minus theta. You can write anything. So cos 90 minus theta is sin theta. So this sin 10 can be written as cos 90 minus 10. Can we write? Yes, by using this, because sin theta is equal to cos 90 minus theta. So this sin theta, cos 90 minus theta. Theta is 10, so that is why we have written 10. Okay, cos 80 degree upon 90 minus 10 is what? 80 only. Cos 80 upon cos 80, the final answer comes 1. So this is how we will solve. Now I've taken D1. This is the D1. Again, sec and cosec, they both are co-functions of each. The co-function of sec is cosec, so they can be changed. Sec, we can write this sec as sec theta is cosec 90 minus theta. Yes, right? Okay, so sec theta is cosec 90 minus theta. So I'm writing this cosec 90 minus 20 upon cosec 70. Are you understanding? Sec theta is cosec 90 minus theta. So sec theta is cosec 90 minus theta. So this is cosec 70 upon cosec 70. Again cancelled, we got 1 as a answer. Similarly, I'm taking question number second, C1. Cosec 12.5 degree minus sec 77.5 degree. So again, sec theta is cosec 90 minus theta. So in place of this, cosec 90 minus, in place of theta we have 77.5. As 90 minus 77.5 is nothing but 12.5. They both came same, hence the answer is 0. Okay, let us come to the question number 3rd, B1 I am doing. It is, they are asking for cos 13 degree, cosec 77 degree. Okay, we know in place of this cos theta, we can write sine 90 minus theta, as cos theta is also sine 90 minus theta. So in place of this cos theta, sine 90 minus theta into cosec 77, which is going on. Okay, 90 minus 13 is what? 77 into cosec 77. Okay, and cosec is what? 1 upon sine theta, because cosec theta is 1 upon sine theta. It is the reciprocal of sine theta, we can write. So sine 77 into, in place of cosec this, we can write sine 77. They both cancelled, we got 1. You write, since sine theta is 1 upon cosec theta. Okay, now let us come to the E1. Again, sine theta can be written as cos 90 minus theta. Here sine 59. Sec theta can be written as cosec 90 minus theta. So you write whatever you have changed. Sine theta, first of all, we change to cosec 90 minus theta. And sec theta, we changed into cosec 90 minus theta. Mention all the things which you have converted. This will give you cos 10 upon cos 10 plus this will give you 59, cosec 59. Here you will get 1 plus, I think you can understand what will happen here. Yes, because cosec theta is 1 upon sine theta, hence we wrote like this, and these two cancelled. 1 plus 1, 2 is the final answer. Okay. Okay, coming to the 4th B question. See, in this question you have cos 65 cos 25 minus sine 65 sine 25. So I'll give you one way of solving this question which you have to remember, because that is very important thing. In such type of questions, if you have, or in such type of situation if you have, so you remember, if you consider a 65 degree, so you change this only. Or if you fix, see, I told you that you need to change only one thing. So in this two, you change only one thing, or you can do like you change these two and just keep these two as it is. So if you change this cos 65 as cos theta is sine 90 minus theta, alright, so this cos can be written as sine 90 minus 65, and this also sine 90 minus 25, and they are already in sine, so just keep it as it is. Okay, are you understanding? This will give you 25 and this will give you 65, and this is sine 65 into sine 25. I am writing it as sine 25 into sine 65. Can we? Yes, because 1 into 2 is 2 into 1. They both are same. So we can write like this. As they both became same, answer will be finally 0. So like this you have to do. Similarly, if you see this question, you can understand this cos and this cosec. If I change this cosec into sec, so this cos and sec, they both will be getting self-adjust. Okay, so we are writing this cosec theta as sec 90 minus theta. So as the cosec theta is sec 90 minus theta, so that is why we wrote this cosec 10 degrees sec 90 minus 10 plus 2 times of cos 59. Again, cos theta is what? So sec 90 minus 31. So 3 times of cos 80 into sec 80, right? Cos 59 into sec 59. Now they both will get self-adjust. I think you can understand. See, always remember cos theta is 1 upon sec theta. Take sec theta that side, so cos theta into sec theta will be give you 1. Similarly, you can understand, no? Like 1 upon, as we know, sin theta is 1 upon cosec theta. Take cosec theta that side. So two reciprocal, that means if the function is a reciprocal and if you multiply, you'll get always 1. And similarly, if you have tan theta equal to 1 upon cot theta, take cot theta that side, so tan theta into cot theta will be equal to 1. So we can understand and we directly write. So this will give you 1, so 3 into 1 plus this will also be 1, 2 into 1. The final answer will be 5. Okay. Okay, similarly, coming to the fifth question, if sine 43 degrees equal to m, then find sec 47 degree. Given sine 43 degree equal to m, we know sine theta equal to cos 90 minus theta. So in place of the sine theta, cos 90 minus 43 equal to m. 90 minus 43 is what? 47. Cos 47 equal to m. And we want sec 47. So cos is what? 1 upon sec 47 equal to m. Take m this side, sec 47. So sec 47 is equal to 1 upon m. Okay. So this is the answer to first question also. Because you were asked cos 47. So it is equal to m. Then this is the answer of second. And third, they are asking tan 47. So I think you can understand tan 47 is nothing but sin 47 upon cos 47. Sin 47 we don't have. So one relation we are going to use. That relation is, let me tell you, as sin square theta plus cos square theta equal to 1. We have already studied. I think you may be remembering it. So what we do, take cos square that side. So sin square theta equal to 1 minus cos square theta. If you cancel this square, so under root of 1 minus cos square theta. So please, you have to write this 3-step in the solution, as this is the part of solution that. So sin theta is under root 1 minus cos square theta. So this sin under root of sin 47 can be written as under root of 1 minus cos square 47. Alright, because by the relation, okay, sin theta is under root of 1 minus cos square theta. So sin 47 will be under root of 1 minus cos square 47. We have cos 47m. So under root 1 minus m square upon m. This is the final answer. Okay, so try to do B and C also. And question number 6th A, B. Up to 6th question you have to do, because those are very easy one. Okay, we'll start from the 7th one. Till that, thank you so much. Have a nice day. Bye bye.